One of the biggest challenges of the 21st century lies in the transition to sustainable energy sources, moving away from climate-damaging fossil energy sources to the widely spread use of solar energy. Solar energy is harvested through many renewable energy sources such as photovoltaic, solar thermal energy, wind power, and hydropower. For example, the electricity demands for Europe could be met from a mere 0.2% of the total area of the Sahara Desert. The technology of solar thermal power plants that heat up a fluid using parabolic reflectors and thereby convert thermal energy to electrical energy by means of a generator is already available. One technical challenge lies in transporting the electrical energy to consumers in Europe, and the solution lies in power electronics. High-voltage direct current transmission, abbreviated to HVDC, enables the transfer of electricity over many thousands of kilometers with high efficiency. With photovoltaic systems, solar energy can be directly converted into electrical current in semiconductor solar cells. In order to feed the DC current from the PV modules into the public energy supply network, it must first be converted into the standard 50 Hz AC current in a solar converter. High conversion efficiencies are crucial. The best PV converters with silicon carbide power semiconductors achieve over 98% efficiency. Wind parks are a common sight along the windy coastal regions nowadays. A country such as Denmark produces approximately 20% of its electricity needed from wind power. Power electronics also plays a key role in feeding the wind power into the electricity grid. The voltage and frequency of the electrical energy produced by these parks must be adapted to suit the transmission network. Due to the fact that the potential for the use of onshore wind power is already exhausted in several of Europe's coastal regions, more and more offshore wind parks are being installed at sea. Some of these wind parks are located more than 100 kilometers away from the coastline, so HVDC is also required for low-loss energy transfer. One of the main challenges of the use of these fluctuating renewable energy sources is storage of energy. Today, pumped storage plants provide part of the expensive balancing energy. Two possible scenarios are being discussed concerning the storage requirements of the future energy supply infrastructure based on the increasing use of renewables. Firstly, the European transcontinental supergrid distributes the electrical energy throughout Europe using efficient HVDC technology. With the integration of wind power from Northern Europe and solar power from the south, energy balancing is achieved. The vehicle-to-grid concept represents another scenario. The batteries in electric vehicles are used as decentralized distributed energy storage for the power grid. Energy management with bidirectional energy flow between the vehicle and grid demands intelligent power electronics. We are experiencing changing times from the carbon era to the age of solar power, and from an energy-consuming society to an energy efficiency society. In the all-electric society vision, sustainable electrical energy forms the basis of the energy supply. We use electrical energy efficiently in all areas of life, such as at work or home, and for mobility and leisure. The key to achieving this vision is power electronics.